Okay, so here's the question. This is from June 2022 on paper 1-3. Someone asked me about this one. And I've highlighted the key information. We've got a line, y equals mx plus c. We've got a point P. We know that m and c are positive constants. Then we've got a curve, which is y equals negative m over x. A single point is also on the curve, such that the straight line's a tangent. So I'm thinking we're going to need b squared minus 4ac, the discriminant, equals to 0 at some point. And we've got to find the coordinates of P, giving the y coordinates in terms of m. Okay, so first step, find out where these two things meet by making the line and the curve equal to each other. Multiply both sides by x to give mx squared plus cx. Then move everything over to one side. So, whoops, mx squared, it's m, oh dear. Mx squared plus cx plus m equals 0. Now we're going to use the discriminant and we're going to set it equal to 0. So c squared, because that's our b value, it's in front of the x, minus 4 times a times c, a and c are those ones, should be equal to 0 for the discriminant. So we get c squared minus, oh, my apologies, just backtracking there, that c there is actually m, because the value c, this c here, and the discriminant is the non-x term. Okay, so we get c squared minus 4m squared equals to 0. So c squared equals 4m squared. So c equals plus or minus the square root of 4m squared. So c equals plus or minus 2m. Now, since c is a positive constant and m is also a positive constant, we can say c equals 2m. Okay. So now we can, what are we trying to find here? Coordinates of P, giving a y coordinate in terms of m. Okay. So I guess we can now say, well, c is equal to 2m. And perhaps we can now find the x value. So we can substitute this, yes, into there. So we should get mx squared plus 2mx plus m equals to 0. This we should be able to solve for the x. So divide out the m's. So divide both sides by m to get this. You can see that this is very easy to factorize into x plus 1 squared equals 0. So x is equal to minus 1. So we've got that. Now we can plug this into the curve equation to find the y coordinate in terms of m. So y equals negative m over negative 1. So y is, of course, equal to m. So our coordinates are therefore going to be minus 1, comma m. All right, so that's that one. I think that's all we needed to do. Now the next part is the normal to the curve at P. The normal to the curve at P intersects the curve again at point Q. Find the coordinates of Q in terms of M. Okay, well, first of all, normal gradient is going to be the negative reciprocal of the tangent gradient. Now, if we look at the tangent gradient, it's y equals mx plus c. So the normal gradient should be negative 1 over m. So we can give the equation of the normal because we have the gradient, and over here we have a point on the curve. Whoops. Okay, so y minus m equals negative 1 over m into x minus minus 1. So y minus m equals negative x over m minus 1. Okay, I think, and it's all over m. So y equals negative x minus 1 over m plus m. Okay, so this is the equation of the normal, and we want to find out where this normal meets the curve again. Okay, so we're going to take our curve equation. This is our curve equation here. It's in terms of y. So, and now we've also got this in terms of y. So if we just take that negative m over x and make it equal to this, we should find where they meet. So negative, what was it? Negative m over x? Negative m over x. So negative m over x should be equal to negative x negative 1 over m plus m. Now, what I'm going to do first is I'm going to multiply both sides by x. Yes, so I'll get negative x squared minus x all over m plus mx. And then we will multiply both sides by m. So we get negative m squared equals negative x squared minus x plus m squared x. Now we're going to bring everything across to the left-hand side. So I get x squared plus x minus m squared x minus m squared equals to 0. Now I'm going to factorize out the x's. So I've got plus x into 1 minus m squared minus m squared equals to 0. And now, maybe I'll move over to here. I need to solve this equation. So x equals, I'm going to use my quadratic formula. So it equals minus, oops, why is it doing that? Minus bracket 1 minus m squared, so minus b, plus or minus the square root of b squared, 1 minus m squared squared, minus 4 times a, so 4 times 1 times c, which is in this case negative m squared, all over 2 times a, so 2 times 1, which is 2. So this will give us m squared minus 1 plus or minus the square root of, now we're going to expand this bracket, first bracket, so it'll be 1 minus 2m squared plus m to the power of 4 plus 4m squared all over 2 equals m squared minus 1 plus or minus square root. Now looking here, we can cancel it and we get 1 plus 2m squared plus m to the power of 4 all over 2. Now, underneath that square root, I can see that I can factorize that to 1 plus m squared all squared over 2. Now, because that's a square, we can then move to this line and square root it, which gives us 1 plus m squared all over 2. And then we, of course, get 2 results there. M squared, right? Because m squared plus m squared is 2m squared, minus 1 plus 1 is 0. So we get 2m squared over 2, which is m squared. Or 0, okay. Is it 0? Yeah. 1 half. Is that right? Negative m squared, m, take away that, take away negative 2 over 2, or negative 1. Okay. All right. And then we can find our y values. Let's just go back to this. So the y values, in terms of m, so maybe we're to ignore this one. Now we can say y is equal to, now it's on the curve, isn't it? So we're going to use this curve equation again, minus m over x. So minus m, now our x value we've just found to be this, over m squared. So this should be minus 1 over m. So our x coordinate therefore is m squared, and our y coordinate is minus 1 over m. I think that should be it. It's a bit of a tricky one actually. All right.